Alright, good morning. We said we'd go over the test questions, so let's go over the test questions. If you missed 1 through 8, you can find them somewhere off to the side. Alright, number 9. We've got a helicopter, we've got a submarine. A helicopter is 450 feet above the surface, while a submarine is 525 below. Which expression models the number of feet the helicopter is above the submarine? So we've got these two numbers, 450, 525, and we want to know what is the difference between the height from the helicopter to the submarine. So if we say difference, it means we're subtracting two numbers. And the two numbers we're subtracting are the height of the helicopter from the height of the submarine. Since this is below sea level, it can't be positive, it's got to be negative. So you say, what is the difference here? It'd be 450 minus negative 525, which looks an awful lot like answer D. And if we want to check this, because just looking at an expression doesn't really tell us a whole lot, if we work this out, if we, instead of subtracting a negative, remember we say we can add the opposite, and we say, what is 450 plus 525? We do that, we get 970 feet difference, and that makes sense. This is 500 below, this is 400 above. We add those together, that's about 900. So this checks out. If you try these other answers, they don't really make sense. Alright, so there's number 9. Number 10. This one a lot of people miss just because they missed this very first step. A centimeter has 3 centimeter, that should probably be long edges, so that's the size of them. If the cube is enlarged so that the edges are twice as long, what is the volume of the larger cube? So I don't really care about the smaller one, I just want a larger cube where all the sides are twice as big. So if we take 3 times 2, we see the new side should be 6 centimeters. So we have a cube. Try to draw a cube here. That's not the best cube, but you get the idea. That's 6 centimeters by 6 centimeters by 6 centimeters. And then we just remember to find volume is area of the base times the height. On a cube, our base is a square. So we say, what is the area of this square here? And we can find that by doing length times width. And then that whole thing gets times by the height. But since it's a cube, we know all these numbers are exactly the same. So we say, what is 6 times 6 times 6? And then this just becomes a multiplication problem. So 6 times 6 is 36, times 6 more is 216, and that is centimeters cubed. Because we're in 3 dimensions, we measure our unit in cubes. Answer J. Alright, number 11. 2 triangles are similar, so there's a keyword, similar. Corresponding sides have a ratio of 4 to 7. Smaller triangle has a side length of 18. What would be that on the larger triangle? Well, we've got all the keywords here, similar in a ratio, find a missing side. This has got to be a proportion. We are comparing a smaller shape to a larger shape. And what makes this pretty straightforward is it tells us this ratio from the small to the large has to be 4 to 7. And I know it doesn't say that in the wording, it doesn't say small to large is 4 to 7, but just if you just think about it, the small would have to be the smaller number. So 4 is that smaller number, okay? So we set that equal to, and it says the smaller triangle has a side length of 18, so small's got to be, or that 18 has to go with the small, so it's got to go up top. We want to know the larger triangle, so that would be x. Okay? Since nothing times 4 will give us 18 cleanly, we cross multiply. We say 18 times 7. So that'll give us 56 here. 50. Okay, 7 times 1 is 7 plus 5 more is 12. So we get 126. We take that number and we divide it by the way we didn't just use. Just 4. So we say, what is 126 divided by 4? And then it's just we divide. 4 goes into 12 3 times. This is 12. 0, bring down 6. 4 goes into 6 one time. 1 times 4 is 4. Subtract again. We're out of numbers, so we add a decimal, and it's 0. And 4 goes into 25 times. So we get something that looks like 31.5. Now we just need to grid this in. So here is your decimal. And so we just match up everything around that. So 5 is to the right, 31 is to the left. Bubble them in. Remember, these blank spaces we don't have to fill in, but you could put in zeros if you really liked bubbling stuff. Okay. Alright, so number 12. So we have two sets, and there's a rule that separates the numbers from set 1 to set 2. So we're saying if we apply one of these rules, if the rule does work, it would go in set 2. If it doesn't work, it'll go into set 1. So F says the numbers are between 1 and 100. Well, if this rule is true, all these numbers in set 2 should be between 1 and 100. Is that the case? Well, no, because we have 216, we have 324, and 412. Those numbers are not between 1 and 100. So this is not our answer. Okay. Second one, the numbers use only the digits 1, 2, 3, 4, or 5. So everything down here should just have a 1, a 2, a 3, or a 5. Well, there's a 6, a 6, a 6, and a 6. So this does not, that doesn't work either. H says the numbers are multiples of 4. Multiples of 4. Well, they're all even, so we know they're multiples of 2. I know 4 is a multiple of 4. 16 is a multiple of 4. So this looks pretty good, but these numbers are kind of big. I don't want to have to check all those just yet. So let's put a maybe by this, and let's check answer J just to see. Let's see how J works. So the numbers are all greater than or equal to 0. Okay, so all of them are greater than or equal to 0. So what this means is that the numbers would be positive. So they're bigger than 0. So that is true for all of these numbers. But then we look at set 1. Is it also true for all the numbers in set 1? Yes. Which means this rule did not split up these two sets, which means this rule is not right. Now that would have been good if all these numbers had been negative, because then we would have seen these are the numbers less than 0 and these are greater than 0. Since that isn't the case, that's not the answer. So that just leaves H. So how do we tell if a number is a multiple of 4? Well, you should be able to divide it by 4 and get an even number. So 4 divided by 4 is 1. Check. 16 divided by 4 is 4. That works. 64 divided by 4, and that's 16. So that checks out. And then if you remember your rules of dividing by 4, you remember that all you need to check are the last two digits. If the last two digits are divisible by 4, then the whole thing is. So 16 we just said was divisible by 4, so that works. 324, if we look at the last two digits, that's 24. What's 24 divided by 4? That's just 6, so that works. And 4 16. If we just look again, those last two digits are 16. We've said 3 times now that this, yes, is a multiple of 4, so the answer is yes, H. H. Okay, we doing alright? Okay. Alright, 13. Laura Lee. Laura Lee. Okay, that's the name. She's got a jewelry box with bases shaped like trapezoids. She wants to line the inside with felt material. Which of the following dimensions will not be used to determine the amount of felt she needs? So just think of the word, if you're not sure what felt means, just think of it like, what's a good description for felt? No, like the material.
What do you use felt for?
Just think of it like carpet, right? She's putting like carpet on the inside of her box because she's cool like that. So, bases are shaped like trapezoids, so we can draw a couple of perfect trapezoids here. Okay, that was pretty bad. Since it's a box, that means it's going to be a prism. Okay, hold on. Okay, so a couple trapezoids drawn just like that. Okay. We connect them to make our prism. Couple dotted lines in the back here. And now we have our jewelry box. Okay, it's got like rings and stuff in it. Here's a nice little ring. Okay, you get the idea. Let's put it inside the box. Okay, so we want to know if she's lining the inside of this, and let's say it's purple carpet. So it's going to go all along the inside. It's going to go on the sides. It's going to go on the back. It's even going to go on the top. So what we're going to need to figure out is, since it's going on the inside, we need all these areas. All these areas. So since it's a prism, we're going to have these two trapezoids. So we need to find the area of a trapezoid. And we're also going to have all of these different rectangles that make up the sides and the front and the back. So let's figure out what would we need, or more importantly, which will we not need to find all these areas. So would we need to know the sides of the trapezoid? Well, can you find area of this without knowing the sides? Of course not. So we need to know that. Do we need to know the height of the jewelry box? Do we need to know this piece of information right here? Well, yes, we would, because to get all these rectangles, the height of the trapezoid is the height of that rectangle. So that's pretty important too. The height of the trapezoid base, so they're saying, would we need to know this height from here to here? Well, if we remember that a formula for a trapezoid is 1/2 base 1 plus base 2 times the height. Well, there's height right there. We can't find this formula for area without that height, so that's got to be it. And then the diagonal of the trapezoid, which means from this corner to the diagonal corner. Well, what good would that do us? Nowhere in our formula for area does it talk about diagonal. In fact, I don't think this year pretty much at all we've talked about diagonals. So this is not important. Okay? So sort of a rule of thumb, if you paid attention at all through the year, and then they say what is not important, and one of the words is something you haven't heard, there's a very good chance that's probably the answer. Okay? If you haven't been paying attention, that trick doesn't work so well, because a lot of these words might not look familiar, which is sad. Alright, number 14. Rudy is reading a map for his vacation, trying to estimate distance between two cities. He knew the map was drawn to a scale of 1 centimeter is 15 miles. If he estimated the distance on the map to be 1.5 centimeters, or 1.5, what is a reasonable estimate for the distance between the cities? So he's got a map. Here's our map. And it says on that map 1 centimeter is 15 miles. And he looked at it. He's got one city here, and he's got the city he wants to go to over here. And then somewhere over here is Pirate Treasure. Let's see if I can't draw Pirate Treasure in a treasure box. And X marks the spot. Okay, all that was extra, but you get the idea. It's a map. It's a map. So if this distance from here to here is 1.5 centimeters, how can we find the actual distance? Well, scale. We talked about this. We talked about this in like a problem 3 questions ago. This is a proportion, and it's set up for us. It tells us we're comparing two things. We're comparing centimeters to miles. To miles. Okay. It tells us 1 centimeter is 15 miles, and we want to know what is 1.5 centimeters equal to. Right? So maybe you can think that if you do 1 times something, will give you 1.5, and that would work, but let's just play it safe. And let's say, what is 15 times 1.5? And that'll give us 75 on the first line, 150 here. Just doing regular multiplication. So that's 225 with 1 decimal place. Change the color so you can see it better. So we get, we get 22.5, and now we just divide that by the number we didn't just use. So we say, what is 22.5 divided by 1? Well, any number divided by 1 is just that number. So we get 22.5. And that would be miles. And that's answer G. Okay, 3 more. Alright, 15. Jacob's got a piece of construction paper that measures 11 by 17. He folded it to form 6 congruent rectangles. Remember, congruent means same shape, same size. So they're all the same. Each of these is exactly the same size. So we want to know what is the perimeter of one of the, it says smallest, which isn't the best use of English since there's only 2 different shapes. This would just be one of these smaller rectangles. So they're all the same size. So what is the perimeter of one of these? One of these. Okay, so we need to figure out what are the length and width of these. So if we consider that 11 inches is the entire height of the shape, and it's split into 2 different squares. It's split into 2 parts. So we need to say, what is 11 divided by 2? So 11, or 2 goes into 11 5 times. So it's going to be 10. Oops. 10. Subtract. And bring down. 2 goes into 10 5 times. Don't forget your decimal. So if we pull out our smaller rectangle, we see it has a height of 5.5. Since we're doing perimeter, we need all the sides, so let's put 5.5 over here too. And now let's find this, the base, or the width, depending on how you want to look at it. So the total is 17 inches, but this one's split into 3 sections. So we need to split 17 into 3 pieces. So we say, what is 17 divided by 3? 3 goes into 17 5 times. We have 2 left over. And let's stick with decimals. Let's see how this goes. So 3 will go into 26 times. 18, and this is just going to repeat. So let's just say it's about 5.6, just for fun. So 5.6 are these missing sides, and now let's just add it all up. And you might get a little angry at this next part, but it's okay. If we do 5.5 plus 5.5, that's the same as 5.5 times 2. And 5.5 times 2 is just going to be the opposite of dividing by 2. So 5.5 times 2 is going to end up back at 11. Sorry. Hopefully you saw that before. Oh, this should be 5.6, not 5. So if we add these two together, 5.6 plus 5.6, we get 2, bring up the 1, and this is 11. This is not the best of answers. Since this was 6 repeating, let's go ahead, let's add another 6. I'm sorry, let's do this again. Probably should have left this as fractions, but I don't really want to work with fractions. If you did this as fractions, you'd probably be done by now, though. So, good for you, fraction people. Okay, 6 plus 6 is 12. Bring up the 1, 12, 13, and then it's 11. So now we get 11.32. And now we need to add those two together, because we need all four sides. We say, what is 11 plus 11.32? We can add a 0 here. That's going to give us 2, 3, and 22. So 22.32. So the whole number is 22, so that gets rid of these. And now we just say, we can look, because we need a fraction here. 0.32, is that 1/2? No, because 1/2 is 0.50. Is 0.32 1/3? Not technically. But remember, 1/3 is 0.33. And 0.32 is really close to that. The reason we can't get exactly that is because we didn't take all of the 6's. Okay? Since we cut it off at 2 decimal places, we're not going to get the exact answer, but we get the closest answer. So the answer here is C. Okay? Hopefully that wasn't too confusing. Alright, number 16, getting to the end. Price for different bottles of orange juice are given to below. Which size bottle has the lowest price per ounce? So per ounce means for 1 ounce. Remember, the word per always means for 1. Let's write up here. Per is 1. So if it says 8 ounces is 48 cents, how could we figure out how much 1 ounce is? So we could do this as a proportion just so we see how this works out. We've got dollars, or ounces to dollars. 8 ounces is 48 cents. And that's equal to, we want to know the price for 1, because the per ounce. So for 1 ounce is how many dollars? But the reason we don't have to do proportions every time is because the simple fact that there is this 1. So when we cross multiply, we're just timesing it by 1, and that doesn't do anything. This is just 48 cents. And so we need to divide that by 8. So 8 can't go into 4, but it can go into 48 6 times. So what is the price per ounce? It is 0.06. So hopefully what you can see is we don't have to do this multiplication part. If we just want to find the price per ounce, it's just a matter of dividing the price for the whole thing divided by the number of ounces. So our next one here, we could say, what is 0.84 divided by 12? I know I've said we don't have to do the proportion, but if you like the proportion, by all means, go ahead and make it, because it's always going to help you stay organized. So 12 into 84, if I just count by 12s, I get 12, 24, 36, 48. Hopefully you're counting on your fingers too. 60 makes 5, 72 makes 6, and 84 is 7. So 12 goes into 84, whoops, 7 times. So this price here is 0.07. Okay. So this is not the cheapest price because this is already cheaper, so 12 ounce, that's not it. So now we're caught between 8 and 20. Let's figure out what this 20 ounce would cost. So we take the whole price divided by the number of ounces. 20 can't go into 1, 20 can't go into 12, but 20 can go into 120 6 times. 6 times 20 is 120. So here we also get 0.06. So if they have the same price per unit, which one has the lowest price? It would be both 8 and 20 ounces. Okay. Alright, and the last one. Which addition of integers is shown below? This one, it's a little silly in the way they set it up, but we're just going to work with it. Since it says addition, so what we're going to do is every term is going to be added regardless of which direction it's going. And we'll see how to make that work. So we always start at 0, and we're going to the right, so we're adding positive 4. Okay. If we go to the second part of this, we're going to the left. So we're still adding because it says addition. But this time it's going to the left, so we're adding a negative number. So we count how many times do we go left. 1, 2, 3, 4, 5. So this is we're adding negative 5. And then we have our third part of this. We're still going to the left, so we're adding another negative. We count the number of spaces we move. 1, 2, 3. So we're adding negative 3. And then our last one, we're going back to the right. So we're adding a positive here. And so that's 1, 2, 3, 4, 5, 6. That's it. Now we just got to put this in our expression form. So we have positive 4. They're all positive 4. That's good. Plus negative 5. So plus negative 5. So this doesn't work because that says minus negative 5. It says plus negative 1. This is where some people are going to make a mistake. They're going to say, well, the arrow stops at negative 1, so I must be adding negative 1. That's not it. You always count how far you move. Not where you end up, but how far you move. So this is not it. So we're stuck between B and C. So we go to the next one. We added negative 3 because we went 1, 2, 3 places to the left. So we didn't go 4 places left, so this isn't right. So the only answer left is C. Let's check our last number. Plus positive 6 plus 6. This is it. Okay. And that's it. So there are all the answers. Hopefully this made some sense. Hopefully you took some notes. And hopefully you've got all these right now. Okay. Good. Go away.